All right, hello everybody. This is Mr. Dilly, and we are looking at chapter 5.3, solving multi-step inequalities. And this is coming from the algebra curriculum from Holt McDougall. So, here's your big learning target for today. That's our Common Core standard that we will be covering. It's talking about solving linear inequalities in equations, right? This is the big thing that's happening. Over here specifically, this is what you need to know by the end of the lesson, right? You're going to be able to solve inequalities with multiple operations, including multiplication, division, addition, subtraction, and distribution. So that's combining everything that we've done in 5.1 and 5.2 and putting it into one equation. And then also, you're going to be able to solve inequalities with variables on both sides. We've done that with equations, and now we're going to do it with inequalities. So let's move on to our first couple of examples here. So just a reminder, the steps you used to solve a multi-step equation, right? And when I say equation, you should be thinking equal sign, right? That's an equation, things with equal signs, can be used to solve a multi-step inequality. And when we say inequality, you should be thinking greater than, less than or equal to, greater than or equal to symbols. That's what makes something an inequality. So here's our big 4 steps here, right? Number 1, the goal is to try and isolate the variable on one side of the inequality. We want just the variable by itself so we can see the values that it takes. Number 2, we want to use opposite operations to remove operations from one side of the inequality. If I have 7x greater than 14, the opposite of this multiplication that's right here is division. And so I'm using division on both sides to eliminate that operation on one side. I'm trying to eliminate all of the operations that are on the same side as the variable. Number 3, whatever operations you apply to one side of the inequality, you must apply to the other side of the inequality. So here I divided this by 7, which means I need to apply the same thing to the other side. We do this so that each step of the inequality is an equivalent inequality. And what that means is that 7x is greater than 14 is the same thing as x is greater than 2. Those two inequalities are equivalent. And that's why we have to do an operation on both sides. Finally, the last thing here, and this just comes up with only inequalities, remember to flip the inequality sign when we multiply or divide by a negative number. So for example, if this were negative, when we write our answer out, x would be less than negative 2 because we would need to flip that sign. And again, we did that in 5.1 and 5.2. So let's do some examples. The first example here, this is a 2-step inequality. We have 3x minus 7 is less than 8. And I should probably put little arms on the 7 so you don't confuse the 7 with a greater than sign. So I need to get the x variable by itself. I need to isolate it, so I'm going to do opposite operations. I want to remove the negative 7 first. So I'm going to do the opposite of that, and I'm going to add 7. And because I'm doing that to one side, I'm going to do it to the other side. And I end up with 3x is less than 15. And again, these two inequalities, this inequality right here and that inequality right there, are equivalent inequalities. So I have that step. Now my next step, what am I going to do with 3x is less than 15? This operation is multiplication, so I'm going to do the opposite operation to cancel it. I'm going to divide this side, this whole side by 3, and I'm going to divide this whole side by 3. So I end up with x is less than 15. And the 3's cancel there, which is what gets your x by itself, and that's my solution. X is less than 15. So x can be any number smaller than 15. Let's do another one. Negative 0.6 times x minus 5, the quantity x minus 5, is less than or equal to 15. So you'll notice that I have this thing on the outside of the parentheses, right? That's a cue for us to distribute. And that's a negative 0.6 that's being distributed. So I'm going to distribute negative 0.6 and get negative 0.6x. And then negative 0.6 times negative 5, excuse me, is, I gotta do this one on my calculator. No, I think it's 0.30, but anyway, to be careful. I mean negative. Yeah, okay. And that's negative 3. So this is less than or equal to 15. I wanted to do that first, and then once I do that, if the rest of the problem becomes what we did on the previous problem. I want to remove the minus 3, so I'm going to add 3 to this side, and I'm going to add 3 to this side, and that's negative 0.6. Notice that becomes 0, that's why I'm not writing anything else on the left-hand side. That's 18. Oops, I forgot my x. And then for our last step here, this is negative 0.6 is multiplying that x, so I'm going to divide both sides by negative 0.6. And so that's 18 divided by negative 0.6, which is negative 30. But remember, I divided by a negative number here, and therefore I have to switch the sign. So this is x is greater than or equal to negative 30. And that's the end of this video of some basic examples. If you go back to the Canvas lesson associated with this particular lesson, there are 3 problems that I'd like you to do. So please do those 3 problems on your own. And then the next video in this series will have those solutions worked out with a couple of other problems. So go ahead and go do that now.